In this example, we want to find the linearization for f of x is equal to the square root of x at a equals 4. So first off, remember that a linearization is just a fancy word for a tangent line equation. So whether you are reading from a textbook that calls it a linearization, or a linear approximation, or a tangent line equation, these all mean the same thing in this context. So I could reword this problem and ask you to find the equation for the tangent line to f of x equals the square root of x at a equals 4, and it's asking you to do the exact same thing. So graphically, let me just give you a quick visual. If we were to look at square root of x, which we know roughly has this shape, then this problem is just asking you to write the equation for the tangent line here at a equals 4. So our goal is to write the equation for this red line. And because they called it a linearization, we would label it as L of x. So we need a point and we need a slope. So let's start with our point. So we know our point is going to be 4 comma something. So to find our y value, we're going to go ahead and substitute 4 into our function. So that would be 4 comma f of 4. And because we're on the square root of x function, when we compute the square root of 4, we know the output is going to just be 2. So our point is the coordinate 4 comma 2. Now the slope of the tangent line can be found by computing the derivative of the function. Now remember, our function, the square root of x, can also be written as x to the 1/2 power. Therefore, our derivative using the power rule will be 1/2 x raised to the negative 1/2 power. Now that could also be written as 1 divided by 2x to the 1/2 power, which is also equivalent to 1 divided by 2 times the square root of x. And this version of the derivative is probably the easiest to work with if you're without a calculator and trying to now substitute in 4 so you can get the slope at 4, because then this is 1 divided by 2 times the square root of 4, which is really 1 divided by 2 times 2, which gives us 1/4. So this is going to be the slope of our line. So now looking at what we have our point, which is 4, 2, and we have our slope, which is 1/4. So we can write the equation for the tangent line with these two pieces of information. So that will be, in point slope form, y minus 2 is equal to our slope of 1/4 times the quantity x minus 4. And if we add 2 to both sides, we'll get y is equal to 1/4 times the quantity x minus 4 plus 2. And again, if you want to interchange that y for L of x to match what you might see in the textbook, you can do that. And what we have here is what we call the linearization for the function square root of x at a equals 4. Now for part B, we want to use our linearization, L of x, to estimate the value of the square root of 3.98. So, because 3.98 is very close to 4, that's why our linearization, our equation for the tangent line in part A, it will work to help us estimate the value of the square root of 3.98. So remember, the idea is that our function f of x can be estimated using the tangent line equation that we've created, as long as we're looking at values when x is near 4. So because 3.98 is close to 4, our linearization can be used to estimate the function that we were given. So the square root of 3.98 will be approximately 1/4 times the quantity 3.98 minus 4 plus 2. Again, I said earlier that the square root of x, the function we were looking at, can be estimated using the equation for the tangent line. Here's the equation of the tangent line that we created earlier. So see, what we've done is we have just essentially replaced our x value with 3.98 in each of these equations. And then you could go ahead and use your calculator to actually compute that quantity, and that's going to give us 1.995. Correction, that is exactly 1.995, so let me put an equal sign there. So our estimate for the value of the square root of 3.98 is going to be 1.995. Now pause here for a second, get out your calculator, and actually type in the square root of 3.98 and see how close our answer is. If you actually type in the square root of 3.98, you'll see that the value on your calculator is 1.99499, which is pretty close to the value that we came up with, which is 1.995. So our estimate is a pretty good estimate. Now, in the next part, let's see whether or not this answer is an over or an underestimate based on the graph. So once again, let's take a look at the graph, and this time I'm going to graph a little bit more carefully. So we know that the square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2. So here's our square root function. This was f of x is equal to the square root of x. And then we went ahead and wrote the equation for the tangent line. Thank you for pretending that this line is straight for me. So my tangent line here at the point 4, 2 is this red line. And so now let's use our graph to determine whether or not our estimate for the square root of 3.98 is an over or an underestimate. So if you were to look at approximately where 3.98 is located, a little bit to the left of 4, and if you were to compare the y value on the square root graph versus the y value on the tangent line, you'd see that because the tangent line lies above the curve here, the tangent line is going to be giving you an overestimate. And you saw that in the calculator as well when you typed in the square root of 3.98 and compared that to our estimate. And remember, our estimate was 1.995. In the calculator, the square root of 3.98 was 1.994 with some additional decimals. So therefore you can see our value of 1.995 was a little bit larger than the actual value. And again, that is because our tangent line lies above the curve here at this particular point. So depending on what your function is, sometimes your linearization may be an overestimate, but sometimes it may be an underestimate of the actual value. That varies depending on your curve at that specific point you're analyzing.